Hey, hi, very good afternoon, everyone. Good morning, good evening as well. We have fairly distributed participation across the globe. Thank you for joining today's webinar series. This webinar series from P Manifold, we are focusing on low voltage DC applications with the objective like how do we really scale up LVDC applications globally. We believe as organization that powering end user proposition to adopt this different LVDC applications and building right financing will remain as key steps to bring the wider adoption. Uh, in this regard, our first topic is mainstreaming solar DC applications. And we have eminent speakers, which I will introduce. Just will use very quick slides to introduce the topic. The DC applications, the DC appliances are on rise. Most of our households are commercials. We are seeing increasing penetration of DC in our life. I have taken example from India, like how some of the prominent DC applications, including DC fans, DC televisions, DC refrigerators, their sales and growth have increased and are expected to grow by almost 50 and 70% in next remaining 3 years. This is a very recent study done by Gogla and quite credible. So yes, the DC applications are on rise. They are happening without getting tied to solar, and with solar tied, I think the proposition further gets strong. How is it happening globally? There are projections that almost in less than a decade, 50% of our consumption will be becoming DC. In United States, this number is already on average standing to 32% of total energy loads are actually DC devices. And with the high penetration of electric vehicles and HVAC DC motors applications, it is expected that for those households, this percentage could go even higher than 70%. So yes, I think this is a significant new trend that is slowly on rise, and it's an opportunity for the industry to take right cognizance and gear up for improving overall system efficiencies in delivery and access. Because the topic is focusing on mainstreaming solar DC. So yes, we have solar AC, quite a prominent power solution that is existing today. But the problem with it, like because of different conversions from AC to DC and DC to AC, from PV to the system to the batteries and then to the load. Our next speakers will talk more details about it. It is estimated that there are some 30 to 50% losses in the system. And that's where I think the solar DC integrated systems makes quite a bit of technical sense. Is it new? Vimal will talk a little bit more on it. It has existed for a long time. There are already DC appliances that are existing in different industries, telecommunications, rails, marine applications. The growth today we see is in low wattage applications and new growing things in data centers, lighting, power of Ethernet, USB powered appliances. So I think these are the new opportunities that industry is really gearing forward to. This webinar between three speakers and stalwarts I know global, we will be focusing on technology landscape, how DC has emerged and where we see it is heading to. We will have a discussion around different use cases and applications and very focused on commercial applications, how it's happening globally. We'll be looking into new innovations and best practices and what kind of standardization, policy, market development interventions are already getting discussed and being intervened at global level. So we will also take a look into that. So with that, I would briefly introduce our three speakers. We have Mr. Vimal Mahendru. He is President Legrand India. He is board member, IC Standardization Committee, and chair for LVDC. His organization, Legrand, is a global specialist in electrical and digital building infrastructure. We have Mr. Venkat Rajaraman, CEO Signi. Signi is a multi-award winning OEM of solar-based DC appliances, and Signi has really done quite good engineering to take the different applications with high efficiency to the market. And we are glad to have William Brandt. He's Chief Engagement Officer for Power for All. Power for All, who may not know, it's a global coalition of 200 plus organizations who are coming together to deliver universal energy access before 2030 through decentralized renewable electricity. So with this speakers, I really look forward for a great discussion. I request all participants to keep sharing their questions as it occurs to them. We are taking note of those questions, and post our speakers make their first presentations. We would take as much questions we can. Thank you very much with that. And I request our first speaker, Mr. Vimal Mahendru, to share his thoughts with us. Vimal.
Thank you very much, Rahul. Can you see my screen?
Yes, it's clear. Thank you.
Okay. Thank you very much for this opportunity. One of the roles that I play additionally of late is of IEC ambassador for sustainability and sustainable development. And this has been one of the important changes which I see taking place within IEC. I guess that all the audience today are familiar with IEC, but just to give a very quick brief on what IEC is, it's an organization. Sorry, can you see my screen? Okay. IEC is an organization which has about 160 plus members worldwide, which means that roughly 96% of global population is impacted by IEC's work and standards. And so within IEC, there is a lot of anticipation of the way electricity itself is changing. I became in 2014 the chair of the IEC's standardization evaluation group for direct current, which was mainly tasked with the idea of trying to evaluate what really is happening with electricity and how it is changing. And being born in urban India, I had actually never been to a place which was a village or a rural township where there was never any electricity. We're not talking about brownouts, we are talking about total blackouts ever since man was there. And to really understand this challenge, I visited a place which is about 150 kilometers from Mumbai to the west, in some Adivasi villages. And there was this one village which had about 22 huts without any electricity. The sole man was sitting outside weaving bamboo baskets for the local vegetable market. This was in 2014. In 2017, thanks to the Prime Minister's various initiatives, this sole man got a solar PV panel on his roof, a charge controller, a battery, and just one LED bulb. This changed his life. Now, the work he was doing outside, he could carry on doing it inside. His daytime working hours extended, his quality of life improved. And this brought about a big change in his own living, life, earnings, livelihood. And this, I think, is the grassroots change that DC has brought about in India, especially rural India. And I believe Venkat is going to talk about it further later on. DC itself is not new. Rahul mentioned in his opening remarks that more than 50% household loads are already onto DC. My understanding is it is much more than 50%. In fact, almost anything and everything we love and like today is already on DC, and we begin to wonder why it is so. DC itself is not new. The first DC network was actually the first electrical network put up by Thomas Edison in New York, what is today the Wall Street area. And this was in 1893 that this network was set up. Even in the 50s, more than 60 years after the first DC network, there was DC in many US cities. In fact, at its peak, there were more than 2,000 DC microgrids operating in different towns in the US. More recently, if you look at USB sockets, what is USB actually? USB is a plug and socket system for DC, for transferring power as well as data both ways. And this has further revolutionized and hastened the move toward DC in ways. So given that DC has been around for a long time, what is leading to this kind of re-emergence of DC? And if you look at electricity in the initial stages, AC and DC were coexisting. Edison was pushing DC, Tesla came in with the current transformer, and because of the transformer, he was able to take electricity over long distances. The fuels at that time were coal, oil, wood fuel. Electricity was considered a novelty and not mainstream. And it was not anticipated, not even by Edison, that electricity would be a most used commodity world over. Right up to the 50s, I think that kind of AC-DC coexisted. But during the Second World War and beyond that, AC kind of took off simply because big power plants could be set up outside of cities, and electric motors became very common for rapid industrialization and mass production. And at that time also the fuel was the same, and environment, energy efficiency were still non-issues. The key technologies in 50s to 80s were more of AC systems, bigger and bigger power stations and transmission lines. Let's look at what has really changed in the last 2 or 3 decades. I think the main thing is that AC is being to see some kind of a challenge. The fuels have changed, and solar PV, which has been around for quite some time, but in the last 2 years it has really come up simply because solar PV prices and the cost of solar PV generation has gone down. Electricity has moved from being novelty, elitist, to a absolute essential necessity. And what has further changed in the last 20 years is that environment and energy efficiency agenda has become mainstream, and the sustainable development goals of the UN have been adopted by every country in the world, and these are becoming themselves a driving force for changing toward greener, better forms of electricity which don't pollute. And if you look at key technologies, electronics, solar PV, batteries, LED lighting, and anything and everything smart. And what is all this that we're looking at? Actually, all of this is nothing but direct current. And without even being very aware of it, the world has slowly but surely moved toward DC. Let me quickly talk about the various use cases where DC is becoming popular, and within IEC we are beginning to do standardization work. I will not dig deep into it, but these are some of these use cases. Data centers is one. It's pretty obvious because in data centers the computers all run on DC, and it's a very concentrated use of direct current. And so it makes natural sense to supply direct current for consumption within the data centers. Public installations, these are all typical outdoor installations, be it street lighting, fountains, advertising, hoardings, traffic signaling, public parks, etc., where outdoor lighting is a common use, or fountains, etc. And these applications are very natural to convert to solar PV based localized power generation and consumption there itself. In fact, in India, there is a huge program run by EESL to convert almost all street lighting to solar PV based DC lighting. The UNDP is pushing direct current for DC microgrids for health centers. In fact, outside of households, which Venkat will be talking of, DC is being used in a big way in healthcare centers, not necessarily for lighting, but refrigeration. Vaccine delivered to rural healthcare centers requires to be refrigerated. And DC is the only way that you can refrigerate in those areas where the grid electricity has not yet reached. Water pumping is another. And the Indian government has today one of the biggest programs in the world for converting rural water pumps to solar PV based irrigation pumps. An interesting use case which is emerging more from the US is about net zero buildings. Try and imagine a building which is as modern as anything that you have known, and that building wants to produce more energy than it consumes. Those are typical net zero buildings. This picture is of a building in Washington, DC, which I visited recently. The entire building produces its electricity on its roof. So including in winters and summers, the heating or the air conditioning is all run on DC. In fact, if you walk in with your traditional laptop, it's almost embarrassing that you cannot connect it without using a special adapter which they would give you for this purpose. But DC has some of its own challenges. The first one is, what really is DC and how do we define it? This typical straight line DC is what you and I read in our middle school, and we thought this was DC. But reality is that in last 30 years, this has also become DC because electronic rectification creates all kinds of waveforms. This is also DC. This again is DC, and is some people call it digital electricity. And all of this is DC. There is no single definition, interestingly, in IEC also, which we can say is DC. So one of the works that we have immediately taken up, in fact, one of the first programs within IEC for standardization of direct current is to start working on some of the key quality parameters of what defines direct current. This is being done jointly by the IEC's System Committee Low Voltage Direct Current, which I chair, along with the Technical Committee 8, which looks after system aspects of electricity. And these are some of the topics which are covered by this group. Let me also mention quickly here that DC is not a product. It's actually a way of thinking about electricity totally independent of alternating current. Why is it that today you and I, when we go to pick up a television or a new mobile phone, we never think about electricity? We just buy it, whatever adapter it provides, we plug it in the wall and we start charging. Because over 130 years, there is some kind of standardization of alternate current that has taken place, which gives you and I the confidence that whatever I buy, it will work with the electricity which is being supplied by my utility operator. For DC, that level of standardization we are trying to compress within less than a decade. And that becomes a challenge. So don't think of direct current as a product that we make one standard and things will work. It's a whole series of standards, and perhaps almost the entire set of standards that IEC has for alternating current will all have a kind of parallel or an add-on standardization work related to direct current. Let me also say the other challenge and perhaps also the opportunity of direct current is this slide that you see. On the left is this old lady, and this was a very interesting story from Bangalore, which was all over national news about a year back. This old lady has this push cart where you will recognize she roasts corn every day. Traditionally, she would do it with a handheld fan, but a local NGO got her a small solar PV panel and a fan on it with a tube light, which is all a self-contained closed loop DC system. And this worked very well for her. She's able to do more, get less fatigue. This whole solution cost her less than $150. And on the right is exactly the same use case, but on a different scale in one of the smartest cities in the world. Some of you might recognize that this is Singapore, by the side of the Marina Sands Hotel, where solar PV panels on the top are generating electricity to run a fan for comfort of people who use this place. The same use case, different sizes. Of course, there'll be different set of standards governing how this whole system is put together. The base technologies of solar PV panels, fan, etc. are same, but how you put it together makes a big difference to the use case. And this is part of the work that the system committee LVDC is doing to try and standardize some of these use cases so that they can be understood. The last slide, I will leave these links for the group if you want to know more about the work of the IEC in this area, the level of standardization and the direction it is taking. I also leave my email ID if anybody wants to get in touch with us. One important aspect is the LinkedIn group, which has more than 600 members, which is purely a thinkers group of what's happening in the world of direct current. If you're interested, would be welcome to join. Thank you very much, and I'd be happy to answer any questions now or later.
Thank you very much, Vimal. I think it was very, very powerful to see how DC has really kind of emerged as a very, very strong candidate and to stay across different markets and across globally. Like we are talking one on rural and low energy tiers users, and we are talking of urban and also industrial commercial applications you covered. So that is great. With this, I request organizer. I think they have a quick polling question for us. Very interesting question. Like, what effect doubling of global sales of solar DC applications will have on its end user price reduction? Lot of question comes across. So I request you, all participants, to please take this poll very quickly, and we will just display the results while we move on to the next speaker. Idea to discuss this question is like, yes, the DC applications are having price higher versus their conventional solutions. And there is a lot of points being said that with more demand and better aggregation, this price can be brought down. So I think the idea here is to understand like how, if that scenario happens that we start doubling up our sales, what kind of a price reduction we can expect in the market. And because the audience is coming globally and primarily from the OEM community, this could give a very important insights. Before we hand over to Venkat, okay, so I think the top answer is like less than 30%. So audience believe that a doubling of sales can actually bring a price reduction of 30%. It's very interesting number because that is also the kind of number which is the cost which these devices are actually higher. So we are really talking of price parity between DC appliances, solar DC appliances, if the sales can be really doubled. So I think that sets up a very good context for our next speaker, Mr. Venkat Rajaraman from Signi. He is an OEM and system integrator who are building these solutions and taking to the commercial markets. Venkat, uh, we are ready to hear your thoughts.
Thank you, Rahul. Good afternoon, everyone. Good afternoon, good morning, or good evening, as the case may be. As I understand that the audience is from across the globe. I need some starting one. I need to share my presentation, Rahul. So I should see some pop-up screen or something here.
Sure, Venkat. Organizers, can we have Venkat's screen? That you must have received some invite.
Let me just see. I have not gotten the invite yet. Maybe it's still showing the quick poll one.
Maybe it is on the back side of your current screen. So maybe come out of your full screen mode and then you can see Venkat.
Got it. One second. Yeah.
Okay, here
Perfect.
we see.
So hope you can see the screen, Rahul and everyone. Okay. Okay, let me get started. I hope all of you are safe and all of you are doing all right in this lockdown times. And even if some of you have started, sort of operations of your facility in a limited way, I hope you are doing it in a safe operating condition. I think Vimal's presentation was very powerful. It's difficult to sort of speak about LVDC after what he articulated. There are three key points that I think he had highlighted. One important one being that LVDC is not a product. It's a way of thinking. And number two, definition of an LVDC itself is fairly complex. Which is what IEC is working on. And number three, you are taking on a system which is 100 plus years old. So which means that if you are expecting anything to happen overnight, especially in this LVDC, we don't expect that to happen, but it's a fairly interesting problem. So with that, I am basically going to talk about from a practitioner's perspective. I know it's a fairly wide range of audience, in this one. But I think I'm basically going to talk about it, from a technology perspective as well as from an applications perspective, and sort of get the ball rolling in terms of where we see things are sort of going to move ahead. With that, I will start off with a brief context of Signi. It's more from a context setting perspective than talking.
You. We are not able to see your screen, Venkat. It's showing all white.
Oh, okay. So
You're full mode now.
I am in full mode, and I am able to see the screen in full mode in my one. Let me just stop the screen sharing and then try one. Tell me if you are able to see the screen, Rahul.
No, it flashed and then it went away, Venkat. Organizers, can you help, please? Yeah, now I can see. Yeah.
Okay, I think there is. I follow the same. Okay, so let's. I think I said that I'll set a context from Signi's perspective, so that it's sort of Signi as a company started off as an incubator at IIT Madras, the Indian Institute of Technology Madras. With the sole focus on LVDC, LVDC from a solar DC perspective, as well as focusing on DC bus architecture. This was, conceptualized by Professor Ashok Jhunjhunwala and Professor Bhaskar Ramamurthy at IIT Madras. So we developed this, what we call it as an inverter-less solar DC technology, focusing on the confluence of solar storage and energy efficient appliances. Of course, the applicability of the same thing to DC microgrid solutions as well. Yeah, so quick timeline walkthrough. We got incubated towards the end of 2014. It took us 2 years to come up with the first product, the LVDC higher capacity product, which was built ground up. And the first product project we had done was in the state of Rajasthan in India, where we had done 4,000 homes. These are all 4,000 LVDC homes where we had put up this the product. Then by 2017, the lithium-ion battery, the storage in LVDC is a very key component. We saw that the lithium-ion battery prices, were falling rapidly, and so we integrated lithium-ion into the product. And then we are also working with, the standardization across the globe. Of course, India led this effort, with a large contribution from Professor Ashok Jinjunwala and Vimal Mahendra, who just spoke, before. So we were able to, we were very proud that LVDC in the world, India was the first one to standardize as part of the BIS standard. So that happened in 2018. Of course, some of the project that what we had done also, gotten international recognition, including the one at the Microgrid conference in San Diego. So far, we have done, over 50,000 installations, all over India in different states of India. So that's the context to which I'm going to talk about, the subsequently about all the LVDC work that, what we are doing. I think before we get there, the most important point I thought I will talk about it. I'm sure William may also talk about it, which is the what we call it the utility 2.0. I'm sure if some of us who have seen this 3-4 years back, it was a novel concept then, but I think it is no longer novel. It's the fact of life now in the sense that we are seeing more and more of decentralized generation sources, and of course more decentralized and more decarbonized, more of renewable energy based generation. And we are also seeing a lot of democratization in the energy mix itself. There is a peer-to-peer energy transfer. There are various energy service providers, and all of them coupled with the digitization of energy. Energy is no longer a black box. I think clearly, people are able to sort of give, more details in terms of how the energy is generated, how the energy is stored, how the energy is consumed. And of course, these are all undergoing, severe disruption. I think, I think it will be, if we say all the utilities, especially in India, they are in deep trouble because this time is for the utilities to change. I think it's time for us to recognize that the energy itself is undergoing a sea change that we have not seen before. And, the faster that we all adapt to this change, the better it is going to be for all of us. Now let's talk about it. What does it take for the LV adoption, to sort of increase, right? So I'm sort of setting a large context in terms of the overall direction. Of course, I'll be happy to take more questions on this. This is also part of several reports, but the one I have taken is the Gogla's report, which is the solar home system market 2023, a looking ahead report. If you see, there are 3 or 4 aspects that clearly stand out. One, if you see the residential rooftop segment, which are all basically 1, 3, 5 kilowatt rooftop, and also another segment which is the solar home system, which are basically a smaller capacity solar home system. You are seeing off late that they are merging into one. There is the differentiation is no longer that clear. They are all sort of you have higher capacity solar home system and you have a lower capacity rooftop solar system. Similarly, you are seeing that there is a lot of DC AC hybrid infrastructure. I think Vimal showed fantastic examples. So if you see, you are seeing several cases where there is the DC consumption inside our homes and offices so high that it makes the logical sense to have a hybrid infrastructure when we are building it. And of course, including India, several countries are now boasting of 100% electrification. But I think what they are not realizing is 100% electrification is also leading to increased demand. And we are also seeing that there is a lot more of DC appliances adoption in the process. Of course, the one big area that we are seeing a focus on is the the productive use applications for for these DC systems using solar energy. I think William may cover this in more, but I'll also talk about it in 1 or 2 slides. Last but not the least, I think clearly, at least from the vantage point that I have as a practitioner, I have as a manufacturer, I see that India is emerging as a possible global hub in design and manufacturing of these LVDC systems, LVDC appliances, and LVDC based sort of the overall the systems themselves. So with that, let me talk about why LVDC. I think Rahul, when he started saying that LVDC can stand by itself, but there is also a need, if LVDC coupled with solar and storage, there is a more powerful case. I'm just showing that case here. So if you see here, a traditional rooftop solar system has a, a panel on the rooftop, and you have, yeah, an electronics which is traditionally called as a solar inverter. And if you need a storage, because most of the time countries like India and other developing countries, you do not have a 24/7. Even if you have, 2-3 hours of power cut, the storage becomes mandatory. You again have this AC to DC converter, which are traditionally called as a battery charger, and a DC to AC converter, which are traditionally called as inverters. So your entire system consists of these three levels of conversion. Of course, depending on the system, you may not have three, you may have a bidirectional converters and so on. But essentially, conceptually, you need to sort of convert this, energy which are generated in DC to an alternating current. Similarly, the energy which is stored in DC into an AC one. If you overlay this on top of all the appliances, I think, what Vimal talked about, whether it is for USB, whether it is for other appliances, your appliances are all moving towards DC. When you couple all of them, then you realize saying that for several interesting applications, you can actually use a DC or sorry, I'll go back. Sorry, on a on a DC or a hybrid of DC and AC. This is what we were seeing as a huge sort of a pull from the work that what we were doing. On the table on the bottom left, you see, for example, a traditional AC appliance. For example, if you have a ceiling fan which is an induction motor based, to a ceiling fan which is a DC based, a BLDC fan, you will see there is a substantial difference in the energy consumption. For example, a fan which consumes over 70 watts of power consumes less than 30 watts in the case of a DC, and this is across fans, lighting, your motors, and pretty much many of these ones you will see this trend where there is a substantial power consumption reduction due to energy efficiency. So now what happens, solar is an expensive source of energy. If you use that with an efficient energy appliances, then your overall levelized cost of energy, it comes down when you have this energy efficiency plus the renewable energy sort of gotten into one, which is essentially what this LVDC is all about, or the work that what we have what we are doing at SIGNI. I will go to the next slide. Essentially, if you see, the same thing can be now extended to DC microgrids as well. I'm the one on the left. I'm showing the a microgrid, which is a traditional AC microgrid. You will see a solar panel and an inverter converting that into an AC, and you will see a lot of loads which are running on DC, but you have an adapters which does this conversion, and your storage, which is again on DC, you do this conversion. So if you see at any point of time, you can see that you can easily lose about 25% to 40% in the overall conversions, all the way from the generation to the end consumption. The one on the right is a DC microgrid, which pretty much eliminates the need for all the the conversions, except for one conversion from the AC side. Which is because of the higher capacity, you can actually do a much higher efficiency converter there, and once you do that, then it becomes a a rather powerful system. And microgrids, of course, is known for its resilience, known for energy cost optimization and sustainability. You couple that with an end-to-end DC, and you provide both a seamless interface to the grid as well as to provide an off-grid kind of scenario, and have digitization of this, and this whole system becomes very scalable, very cost efficient. That's the a big advantage of LVDC microgrids. Now, I think let me briefly talk about why DC now. I think I'm not going to talk about the war of currents, or what had happened between Dr. Edison and Tesla and so on. But what we need to see going forward is, I think there is a tremendous advancement in power electronics integrated circuit. So today, if you see a smartphone, it integrates a camera, it integrates several of them in a single semiconductor, which was not possible 2 decades back. And that, coupled with the rapid drop in the prices of solar PV and the lithium-ion battery, makes this entire LVDC very attractive. Of course, with the advancements in the motors, especially with the onset of electric vehicles and the BLDC and PMDC motors, and the evolution of the safety standards, because the DC at a ELVDC level is inherently safe. You see a tremendous adoption. So what I'm trying to show here is what used to be, about 25-30 years back, all our laptops and personal computers, which became into mobile phones, which were running on DC. Then about 15-20 years back, the lighting moved on to an LED lighting. All the computing devices, the televisions that what we have, the LED, LCD televisions are DC, and you add that to a coolers, to a water pump, to a, air conditioners or refrigerators, and the big mother of all is the electric vehicles. All of them today are on DC, all of them are on LVDC. So now what happens is, if all of them were to sort of come together, it sort of presents a very powerful picture in terms of the adoption that what will happen going forward. Of course, the LVDC adoption is everywhere, all the way from our homes and offices to productive use applications, to solar water pumps, to electric vehicles, and even a grid level storage system. India is embarking on a large project for a grid level storage, and these are all again LVDC based storage that are getting popularized. So I will basically now talk about the applications for this in the next few slides, and then maybe conclude. I think one big powerful application we see is in terms of productive use appliances. Unfortunately, I think that needs a webinar by itself, because this is a very important topic. But all I'm saying is that a productive use for livelihood generation, especially for rural, DC is playing a large role already, right? I think Vimal touched upon on the solar water pump. We are doing projects, for example, on the digital centers. We are doing for agricultures, which are where you need the cold storage, where you need the freezers and chillers and so on. And of course, textile industry, especially in India, is a large consumer for DC, because most of the power looms which are traditionally based on induction motor is moving towards a BLDC motor, where couple that with energy intermittency and the need for diesel generators, this becomes very powerful. So this I'm going to not delve deep because of want of time, but I'll be happy to take any questions if anyone has. I'm just going to talk about only two examples which we found absolutely stunning. One, you take an example for a digital center. These are all the centers in the tier 2 or tier 3 towns and places where you need to so for example, India has a large UID initiative, what they call it as an Aadhaar. There is a need for scanning, there is a need for printing, all of this kind of for the one. What we are finding is that if you have a rural digital center where you need a computer, maybe a laptop, a printer, and a scanner, and maybe a network of equipments along with some lights and fans, you see traditionally, if you want to power this, you may need 1 to 2 kilowatt of traditional solar system, which is more expensive, and also it's a sort of you need a larger rooftop space, and you need a larger space for your batteries and so on. Now, all of them can be powered by the small appliance, what is shown here, which is powering about 500 watts. This 500 watts can power all of these appliances, provide the necessary backup time, interface to the grid, and run a digital center. When we had done this, this project, we realized saying that from a costing perspective, though the appliances and all are as I think the poll also correctly pointed out, we are at about 20 to 30% more expensive, just because there is no economies of scale. Even in that aspect, this system makes more economical sense than going for a traditional solar AC based system. The second application we found very powerful was a smaller water pumps. We have done quite a few of them in India. These are all pumps where you just need it during the daytime. You take it to the field, pump it from your stored water to the fields, and the evening you bring it back and then light your lights and fans inside your home. These are all so easy to hand carry, because the system itself is small, and that is possible because of the LVDC, as well as with respect to the smaller form factor of this entire system actually. And then of course we have also done one large project. I thought I'll give an example so that it's also for many of you may have already visited this research park at Chennai. This is a 1.2 megawatt solar which is on the roof of these buildings. There are 5 blocks are there. There is a seamless integration of the solar to the incoming grid. we do have, and the main distribution across the floor is also DC distribution at 48 volt, and we also have selective 380 volt distribution. And all the appliances, the lighting, the air conditioners are all done using the a VAB and a thermostat control air conditioners, and it integrates a solar and a storage, so that the clients who are part of this building has an ability, they can have an option not to take a diesel generator as a backup and then go for a DC. This is a large facility, over 1 million square feet, and this can be sort of replicated across in very many places as well. I just showed it because LVDC can actually cover a wide gamut, all the way from a rural application to a very powerful urban projects as well. I think few places where we were finding it absolutely lends itself well. One, for an affordable housing. India is embarked on a large project for affordable homes, and these are all homes which are away from the main city. These are all homes, as the name indicates, where these are all 1 or a 2 bedroom kind of homes, mainly sort of, so that it is an affordable. And we found that there is a lot of grid intermittency there. The solar and the DC is very powerful, in those applications. Of course, educational institutes also a large this thing. We have done several of these projects. The reason for that is the load pattern, sort of matches with the solar generation. And most of the loads in these educational institutes, in the classrooms, in the hostels, are all mostly the lighting and cooling loads. So we found that it lends itself well. And of course, we have done a lot of the smaller installations as well. The ones where we found enough traction was smaller shop owners, where he has a light and a fan and a small, maybe a small laptop or a point of sale system. That can be a DC. Similarly, if somebody has a home with a small water pump to run, that could be there. And similarly, the small offices, for the microfinance institutions or the digital centers, that can be run completely on DC. We had also seen that a typical payback period, even with the battery storage with the solar DC, we can do it at about 3 years or lower. And with the energy efficient appliances, basically, your better usage of the solar energy. And places, countries like India, you have the telescopic pricing for the LT consumers, especially if you are a home consumer. If you are consuming more than 300-400 units of electricity, you pay 6-7 rupees, whereas if you're consuming 50 units, you are paying only 2-3 rupees. The telescopic pricing lends itself well for a solar DC application, because you can do a peak shaving there. And of course, it avoids this lead acid battery and the fumes, which we all know, what is associated with that. And of course, this 50,000 LVDC systems that what we have installed also helped us to sort of refine and then sort of improvise the products and so on and so forth. This is the last slide I have. I think, what does it take for us to mainstream this solar DC, right? I think this is the key one, because the benefits are very clear. I think we talked about it from a technology perspective. It is adaptable, it is scalable, and of course, this is cost competitive, and of course, it lends itself well to productive appliances. A lot of skill development is possible, and of course, there is a sustainable livelihood opportunity along with the community empowerment. What is needed now, right? What does the, from a practitioner's perspective, now, clearly, I think one need of the hour is standardization of these products and systems. I know Mr. Vimal Mahendru heads this, I think, taking this head on. We need this to be standardized at an international level, both at IEC as well as at the IEEE level. We do need policy frameworks, especially from the bureaucrats on the LVDC. Today, if I go and install a solar AC system, I am eligible for a subsidy. But if I need to install a solar DC system, I need to go through a hula hoop to sort of get the same subsidy. So I think policy framework should lend itself well. Doesn't matter whether you are doing a pure solar AC or a DC. And we need to be building a capacity across the value chain, because we are just scratching the surface as I see it. And of course, the cross-sector linkages, I think Vimal talked about healthcare. I think we have an opportunity in agriculture. We have an opportunity in education. I think the cross-sector linkages to meet the sustainable development goals are key. The last but not the least is absolutely important to have quality standards, quality certification, well-defined QA program. I know smaller solar home systems have now a very powerful program using the Lighting Global and so on. we need that now to be adapted to that basically only up to 350 watts of power. I think that needs to now change to accommodate a larger LVDC product, so that we can whether you buy it in anywhere in the world, you can get to the same product and same standard. That of course would help us in catalyzing the finance, which is absolutely required, because I think this is a multi-billion-dollar opportunity for all the OEMs and the practitioners out here, and I think we need to drive this from these angles, so that I think we can provide a powerful solution to our customers. So with that, Rahul, I will stop my this thing. If there are any questions, I'll be more than happy to take it up, Rahul.
Sure. Thank you very much, Venkat. Very powerful presentation. Thank you indeed. Your 5Ds, I remember it. I think that was very good. And I think you very briefly touched upon hybrid, and that itself becomes a topic of another webinar, which we will host shortly. And another thing you mentioned, like another webinar focusing on productive use. And I think our next webinar actually dives deeper into the solar water pump application, which both you and Vimal touched. I think with that, quickly, organizer, do we have a polling question? So I think this Venkat in his presentation did touch upon this new trend where he expects that solar home systems and solar rooftop kind of converges. We are extending that question, like our households are already having multiple households, fair amount are having currently grid inverters today. Question is like, when the replacement of this grid inverter and battery lifetime comes, could solar home systems become a replacement opportunity, and how much market share solar home systems can capture from this grid inverter replacement? So the options are less than 20, less than 40. Of course, your answer may be greater than 50, greater than 40 as well. So please help us see like what trend you believe that globally, not limited to only India. I think you will represent the answers for your country. Okay, so I think like a high proportion, almost 20%. So people believe that 20% of grid inverter replacement could be taken up by solar home systems. There are a higher amount which says less than 40% also. So I think between 20 and 40%, let's hope that magic number, because that itself will give a very strong boost to penetration of solar DC applications. With that, I now request William from Power for All to share his thoughts, especially coming from access to energy applications and how LVDC and solar DC is producing new solutions in those segments. William.
Thank you so much. Can you hear me and see my presentation?
Yes, William. Thank you. Loud and clear.
Wonderful. Thanks so much for including Power for All in this webinar. It's a very timely topic, as we've alluded to a little bit right now with the COVID response and the lack of electrification for many rural healthcare centers. These types of DC applications for vaccine refrigeration, as well as other medical devices, is becoming more and more important. So kudos to the organizers for organizing this at this time. So in terms of what I'd like to talk about, just very quickly to introduce you to Power for All in case you're not aware of the organization. As mentioned, I'm going to talk a little bit about agriculture and productive use as it relates to DC appliances. I'll briefly touch upon policy and some of the views that the sector has on what types of interventions are required, both on quality and market development. And then picking up on Venkat's earlier comment about manufacturing and whether India can become a hub of design and manufacturing, I'd like to just very briefly touch upon that as well. So Power for All, we're a coalition actually of now more than 300 organizations, and our essential role is we're an evidence-based campaign looking to build markets for decentralized renewable energy solutions. And that's everything from mini grids to solar home systems to appliances. Appliances has become a much bigger part of our focus over the past 2 to 3 years. Amongst our partners are organizations like Energy Savings Trust, CLASP, and Efficiency for Access Coalition. If you're not familiar with those organizations, I highly encourage you to take a look at their websites. They are by far and away the leaders on this topic as it relates to last mile electrification in both household and productive use appliances. So essentially, we're trying to create the political will and financial support to scale these types of solutions. And our approach is very much an ecosystem approach, trying to make sure that we are looking at all parts of the value chain as it relates to not only electrification, but also the benefits of electrification to healthcare, to agriculture. And so we take a very integrated approach to electrification. We're not an us versus them type of organization. We work very closely with utilities and other stakeholders to ensure that the energy systems of the future are fully integrated, so that distributed solutions like solar home systems and mini grids are fully factored into how countries are looking to electrify, rather than doing what we did in the United States, which is where I'm from, which is retrofit the grid to absorb these solutions. Instead, many of the countries where we work have the opportunity to create an energy system of the future that builds these things in an integrated fashion from the very beginning. And so we're doing work in Uganda right now to really prove that out. And I encourage you to take a look at our website to learn more. As I mentioned, we not only look at how we need to work with the energy sector to better integrate these types of decentralized solutions, we're also working with what I would refer to as the customers of these solutions. So how do we show the Ministry of Labor that the ability to create employment is improved through these types of solutions? How do we show the Minister of Education that they can have better education outcomes through decentralized renewables? Same for healthcare and also for agriculture and food. And so I wanted to talk very briefly about agriculture to start off. And I think that most of the people on this webinar are probably very familiar with the challenge that we're facing right now. And this challenge has been aggravated further by COVID with disruptions to international supply chains. You're starting to see many governments in Africa, sub-Saharan Africa, where we work, and elsewhere, starting to look at globalization a little bit differently. And they're starting to think more about, how do I recalibrate my development strategy so that I'm not so reliant on globalization, but I'm also thinking about, how do I ensure that I have local capacity if these types of disruptions continue or get worse in the future. And that's certainly true for the food sector. Food security is already an issue in sub-Saharan Africa. It's certainly been aggravated by COVID. But even before COVID, there was very high levels of undernourishment. Most of the agricultural work being done there is by hand or using animal power, so the mechanization level there is quite low. Much of the land is still rain irrigated and not irrigated by pumping. And then you have the huge issue of post-harvest waste. So there's really opportunities, and that's largely due to the lack of refrigeration. And so you have across the value chain of agriculture and food opportunities to introduce appliances and applications that can address some of these challenges. And that starts with solar irrigation. New data put out last year by IFC and Dahlberg looked at potential applications for productive use appliances in sub-Saharan Africa. And their conclusion was that, without question, irrigation was the most ready to be commercialized, followed by refrigeration. And as was mentioned earlier, India has really led on this front with its Kusum initiative to scale solar irrigation for smallholder farmers. But this is a huge market potential, $1.6 billion, according to this report that came out last year, by 2030. and that's probably underestimating the value of what's possible. But I think that the focus on irrigation is very important. Increasing agricultural yields is essential to improving lives and ending hunger. But we also need to be thinking about, okay, if I'm increasing yields by creating new opportunities through irrigation and solar powered irrigation, what do I do with those increased yields? There has to be a solution. There have to be solutions in place to process that yield, to store that yield, and to transport it to markets. And so, you know, we're starting to see early phase applications like milling, threshing, grading, pressing, and drying to start to come to the fore a little bit more. It's still early. The economics don't really work, nor are the policy frameworks or the standardization in place to really scale those just yet. And there are also some other applications that are small today, but also hold promise, such as egg incubation, milking, electric fencing. So there's a lot happening in terms of design and innovation beyond just the irrigation aspects of things. And some of that innovation is being done by an organization called the Access to Energy Institute, I believe they call themselves, A2EI, another partner of ours. And they've looked, or they're in the process actually, they haven't published this data yet, but it's coming out probably sometime this month or next. And they've evaluated 10 productive use technologies for agricultural use in East Africa, looking at unit economics, desirability, and scalability. And their initial findings, and this is of course very regional and preliminary, but their initial findings indicate that there are 3 applications for agricultural processing that look quite promising: oil pressing, rice hulling, and peanut shelling. Milling is sort of we're not sure yet. And then the ones in the right column, they believe today, at least in East Africa, are probably not likely to be commercially viable. And there are a variety of reasons that I can go into in more detail. But this is quite exciting. This type of data and information did not exist even last year. This A2AI was founded by the 2 co-founders of a solar home system company called Movisol. And they're doing some very valuable work, as are other organizations like the Rocky Mountain Institute, which are looking at specific crops and how those crops fit with potential off-grid solutions for processing. And so A2EI is looking at also within the oil press scenario, they're looking at, you know, what types of machinery are best suited for these types of off-grid settings. And they've discovered, for example, that hydraulic oil presses are much more productive than traditional oil expellers, and also have a lower cost, operations cost. So they're not only producing more revenue, but they're also requiring less in terms of operational expense. So this is data that will be contained in the A2EI report that's coming out soon. And so I encourage you to take a look at that. There's also individual companies like the one mentioned here called AgSol that's working on off-grid milling technology. There's a lot of work happening on mini-grid milling solutions as well, but those are typically 3-phase or 1-phase AC power. AgSol is a standalone solar solution that's looking at off-grid electric mills, and you know, relative to what smallholder farmers are currently paying for diesel generation, this makes significant economic sense. It still has to be demonstrated in market and shown to have, and I think also one of the big aspects is understanding farmer demand and what they are looking for in terms of product preference, but a lot happening on the agriculture side. So that's a brief introduction on agriculture. And I also wanted to touch very briefly on some of the policy needs for DC appliances in sub-Saharan Africa. There's some reports that the Efficiency for Access Coalition and CLASP have put out And I think just want to start with what some of my colleagues have mentioned earlier around standards, and using those standards to ensure quality. I think that DC appliances in our sector have, up until this point, largely been more consumer use products, lower ticket items. And as we move into productive use, where the cost of these appliances increases, as well as potentially entering into some mission critical situations like healthcare, you don't necessarily want to delay the development of standards, as maybe was the case in some other more lighter consumer product goods. So as we move, so there's I think different points of view on when to start to introduce standards. I think for the bigger ticket items, for mission critical appliances, it probably makes sense to introduce those standards earlier than later. But this is basically the sequence of how standards are introduced. First, test methods are determined to make sure that everybody's evaluating the quality and performance of their products in similar ways. They typically would then introduce voluntary standards that allow for the industry to get used to actually producing these goods at scale within those parameters, and also starting to do awareness raising, put the financing together, figure out what tax exemptions are necessary. So that sort of then leads into the more mandatory standard phase, and then labeling. For the off-grid lighting sector, we're just now starting to see a unified labeling system. So yeah, I could imagine that for productive use appliances, this is going to take a number of years to try to come up with a hopefully regional, if not more international, harmonized standard platform, so that instead of having to deal with standards on a national basis, OEMs and manufacturers have the opportunity, as well as practitioners have the opportunity to have a more uniform set of standards by which to plan their businesses around. And then also outside of standards, there are other elements to policy interventions that are needed today. Certainly quality is a big piece of that, but also ease of doing business, as you'll see in the left column here, is also very critical. You're seeing a lot of VAT taxes and other customs tariffs or punitive tariffs that are put on some of these products in many of the countries where we work. There's always foreign exchange constraints that prevent scaling some of these solutions. Market awareness is very low, certainly amongst smallholder farmers. That's the case, and we're starting to do with partners some initial surveys to understand what is the demand profile for smallholder farmers as well as farming collectives. Access to finance continues to be a big challenge. We can get into some of these later, but I've talked about quality and standards, but the other point I would just make is that it's not just about working in the energy sector. As we are finding in our work in Uganda and elsewhere, you really need to be building bridges across different sectors. In the case of agriculture, interministerial working groups to make sure that policies are harmonized across those groups, that the private sector is fully engaged with the public sector to ensure that the most efficient use of capital is being deployed, as well as customer service is being well taken care of. So those are some high-level thoughts on policy. And then just to pick up on Venkat's point earlier about manufacturing, just very briefly, I spent about 15 years in China, and China up to date has manufactured most of the off-grid appliances, whether it's fans or the lighting solutions or whatever it may be. And I recently had a conversation in China. I said that you'll start to manufacture pumps in China as well, pumps for irrigation. And the response was, no, we're going to source those from India. And again, I think this given the situation that we're in today with COVID and disruptions to global supply chain, I think we're looking, as well as looking to relocalize some of the value chains to the national level. I think we're going to potentially see a shift in where manufacturing or assembly of goods is taking place. I'll end it there. Thanks so much.
Thank you very much, William. I think it was a wonderful presentation and sharing your perspective. I think one thing common across all three speakers was a solar water pump. And I agree that we really need to focus to really explore how to really make this mainstream. With this, let me ask our organizers if they have a quick polling question. So I think this connects to what Venkat talked about hybrid. The question here is like for solar grid and battery tied power backup solutions, which are becoming more and more prevalent now, what kind of power outputs from this solution box you see that will capture the market share globally in next 3 to 5 years? Will this boxes continue producing AC output only, which is currently the major trend, or DC output only, or the hybrid, which is basically AC and DC outputs both? So if participants can quickly share their views from their respective countries, that would be great. Okay, so I think the results are fairly kind of talking the importance of hybrids. So almost 77% strongly believe that the systems have to start producing more both AC and DC outputs. And I think that possibly is a first good question, just connecting with this poll, that I would want to discuss with our experts. India at least has seen a very new, so like Venkat mentioned, like how increasing electrification will create more demands for new appliances and applications. That also has seen a little different trend, like before electrification, lot of solar DC appliances through government tenders was actually focused on rural applications for improving energy access. And with improved grid scenario, lot of those systems has got into a challenging scenarios, like lot of them have been junked as well. So between this combination, I think it becomes very important uh, how we kind of adopt hybrid solutions where we are able to cater to both AC and DC needs and supplement both needs, and let the market then really evolve, picking one over the other or both kind of coexisting, as Vimal mentioned. Vimal, what do you think about hybrids, and what cue the supply community needs to take and gear up to this new trend that is reflecting strongly globally?
Thanks, Rahul. Well, my personal view on this is that AC is not going to be replaced very rapidly, or let's say in less than a decade, by DC. AC and DC are likely to coexist for at least a whole generation. And the reason for that is also very simple. In almost every country of the world, today's electrical systems, be it power generation, transmission, or distribution, are owned by governments. Typically, these systems are put in place with a life of 70 to 80 years. In India itself, till 10 years back, we were investing in power plants, which were traditional huge power plants, coal-fired power plants. You think the Ministry of Power or the Indian government is going to say, okay, scrap all these? Of course not. So those power plants which are owned by the government, it's government investments, they will remain, transmission lines will remain, DC will be coexisting with this. What we are likely to see is, and this may take over a generation to transition, that DC coming into the loads. That means from the bottom up, from the consumption side upward, DC will start moving, and it will be replacing AC use case to use case. It is quite likely that as more and more net zero buildings are adopted, for example, in cities, the requirement for AC will start to go down. It could be that a building which is net zero, right next to it could be a building which is traditional alternating current supplied building, where only the loads are still DC because they just put it into the traditional plug and socket system. So don't be in a rush. AC and DC are here to coexist, but for sure, the movement is very clear and it's taking place toward DC. May I just also quickly add that in IC, we are cognizant of this change. And because of this change, we are likely to see a kind of standards also for this transition. Because you can imagine the challenge if every country makes its own transition plan, its own standard for transition from AC to DC. So kind of international standards which will enable the transition so that we continue to extract value of our AC asset. Thank you.
Okay, great. I think that is very thankful. Venkat, what are your thoughts, Venkat, on hybrids and the need of them?
Yeah, I think it's a very interesting question, Rahul. Today, I see a lot of echo. Is that only for me, or are you able to hear me all right?
Even I'm hearing a lot of echo.
I'm not, but I think like let's put up a sun mute so that one of us is speaking.
Okay. Yeah. So today I think if you see this gamut of appliances that we talked about, whether it is for your lighting, whether it is your televisions, whether it is your fans, whether it is your water pumps, all of them, the appliance today work on DC. And what you are doing is you are adding your AC/DC converter in the front. Right? Every ceiling fan that you buy has a converter which is added to the device itself. The reason for that is it has to be compatible to AC. Right? So the point is, as absolutely Vimal pointed out, this is not going to be an overnight change. I don't think any one of us who are the practitioners, we knew that it is going to be. I think it's going to be a hybrid AC DC system is what is going to sort of evolve. I think the requirement is today, if you are a ceiling fan manufacturer, for example, right? It's without too much of a change. It's easy for you to provide the same fan as the DC input and as a traditional AC input as well, right? So this is applicable to the fans, to the tube lights, to the bulbs, to a lot of these appliances. If you are able to make that transition happen, then the DC adoption will automatically sort of become better. That you couple that with the distributed generation on our rooftop and then so on and so forth. So I do believe that it's going to be a process, but I do see there is definitely an hybrid AC DC infrastructure is the sort of way to go into the future as we move ahead.
William, just extending this conversation to sub-Saharan Africa, I think like the lot of focus and volumes for this intermittency is fairly weak. I think India has overcome that journey, and I think that's why we are seeing a little struggle with the existing energy for excess market in India, and a lot of focus moving to Africa. How do you think the market trends for hybrids in Africa?
So, I mean, I think one of the topics that I'm hearing some feedback, so maybe people can go on mute. But I think this is not just a technology issue; it's also one of political economy. And this involves government, it involves donors to those governments, development entities, all of whom are working from a legacy that is very fixed, I would say, based on my experience. And so it's very challenging to overcome that. So I fully agree that this is a process. and I think it's going to have to require almost a generational change in leadership for it to happen. I think where we are today, it's just, there's just so much legacy thinking. I will say that even in India, though, I would argue that, the government, while successful with its Saubhagya initiative to 100% electrify all households, I think they're also finding that it's very challenging. And, they're looking at different models for how to integrate decentralized solutions into the discoms so that there's, good last mile service provision and that there will be, I think, also in India, hybrid systems and solutions. They already exist on the ground today, even if they're not recognized. And I think that that's going to probably continue. In Africa, which is, I would say, probably at least probably 10 years behind India in terms of, it's 50 countries, it's 60 countries. You can't speak about Africa in one breath. So it's more complicated than that. But in general, it's further behind India in terms of where it is in terms of market development. It also has less population density in many countries. Those are both blessings, I hope, that allow for a faster transition in these markets. And I think perhaps you may even see an outside-in dynamic where, because grid extension is so stifled in many of these countries, and rural electrification through off-grid systems is advancing quite quickly, you might start to see a reverse influence by what's happening in more rural areas into the rest of the electrical system. And again, that's what we're trying to show in Uganda. I mean, we're not saying we want to take over the utility. We're saying to the utility, who's our partner there, you need support from the private sector. You need support from innovation. You need support across the board to meet your electrification goals. And that's where private sector companies like Venkat's, can really step in and create a much more powerful public-private partnership, which I think, if I'm hopeful, that may result in a maybe a little bit of a different balance in hybrids as the market develops there.
Thank you very much, William. I think like both Vimal and Venkat have said that we should not expect this transition in an overnight time. It will take pretty much a generation. I think like lot of OEMs, like I think if we even look into the numbers for DC solar appliances, I produced some numbers from Google for India. I think we are still in thousands, while the market of the current thing is in millions. Can you kind of share like what are some of the barriers? And solar DC has been existing for some time, right? It's not something that we are talking for this year or only last year. What are some of the significant barriers which needs to be taken care? So like if each of you can pick up like one or two of those significant barriers and really help, because the focus of this discussion is mainstreaming. How do we really mainstream this application for mass adoption and include both the rural and weak grid markets as well as the urban and relatively better grid and on-grid markets? So I think we can start with William and go in the reverse order this time.
Yeah, thanks. So it's funny, Power for All celebrates its 5th anniversary this month, and I just had a call with some of our alumni yesterday, and I was asking them, what one thing did they think was needed to fully unlock the potential of these solutions in rural settings, because that's where our focus is mostly on rural environments. And two things I think came across. One was consumer finance, or sort of end user finance more generally, and subsidy for that. These are very poor people that we're talking about. Many of these countries don't have the financial infrastructure in place to support these types of solutions, especially if you're getting into the productive use side, which is obviously higher end. There needs to be subsidy in place on the demand side in order to make these things scale. That's just a fact. And I don't think that there's anybody who would argue that, that hasn't been the case in all markets over time. So I don't think we're talking about anything different. The other thing I would say is that, because we're talking about very poor people, the DFIs need to step up their game and take a much bigger risk profile, so that these things can scale. Right now, we're stuck in sort of still small amounts of money. The gap is huge. The risk appetite is low. And we're talking about 1 billion people here, right? So, the DFIs need to take a much more aggressive approach, I would say, that's more open to greater risk. Those would be maybe two of the things that I would call out.
Okay, I think that's great. So I think you are kind of supporting that demand side subsidies would really play an important role. Venkat, I think you also mentioned about it in your suggestions about mainstreaming, about policies kind of supporting this thing. What maybe I think what is that one thing that you really feel that will drive a change maybe in a short term for seeing improved sales of solar DC systems?
Right, Rahul. So I think this was I think Vimal set up the context absolutely right. We need to remember that the AC systems had taken 100 years. Okay, so which means that if you look at the amount of standardization that has gone, right from your circuit breakers to your switches to your electrical control circuits to the appliances to the grounding to the safety, enormous amount of effort has gone in there, right? So that's why there are giants who are there who have done this. So so I just want to set the context saying that this is not slow to pick up. This is what is expected, because I think we have a lot of ground to cover before it it really becomes a mainstream. But having said that, I think the 2 points that I just want to bring out, I'll leave the 2 points that what William had talked about, catalyzing the financing part and the DFI. I see the most important thing is standardization. I know Vimal is going to agree with me, because today, I wouldn't know whether there are products which are at 24 volts, at 48 volts, at 60 volts, at 230 volts. So I think it's a challenging problem, right? Because this is not, and we all know that it has to be sort of treated at a systems level. I think that's a so I think this is a beast that I think we are trying to take head on. This is something that got to happen, because that's something sort of going to, that universalization that had happened in the AC industry will have to sort of come. See, the adoption is clear, the trend is clear. I know several years back there were a lot of naysayers, right, saying that, hey, 100 years back DC was there, but we did not sort of pick up what. And I have seen in Kolkata 60 years back DC. You don't see that arguments coming up anymore, right? People know that the call centers or the data centers are DC. That the Washington DC, the offices which are right in the middle of a financial center is all moving towards DC. So there's a trend which is happening. The standardization and quality standard of the available product. If you ask me, these two would be the most two critical factors for a large-scale adoption of DC.
Sure, thank you very much, Venkat. I think I definitely agree that this will definitely really help mainstream. I think improvement in quality will also drive improving the proposition of this appliances, including reliability. Vimal, what is your take? I think the answer is kind of little bit preempted.
No, but I'm glad that I think William and Venkat have touched the two most important points in this: finance as well as getting the right standards out. I will just add one more thing which goes beyond this, and this is my personal experience, nothing to do with my role in IEC or in my corporate life. I feel that it needs a bit of a mindset change. Somewhere we are still thinking AC. Gone are those days. I think, smell the coffee. The world has changed. Electronics is everywhere. You cannot run a single device which runs on electronics with AC. You need to convert to DC. So guys, The world has changed. Lighting, which was just about 20 years back, we were all using the GLS, which was a 100-watt bulb for mere lighting any of the rooms we are sitting in. Today is very well lit with a 3-watt or a 5-watt LED bulb. So where has electricity consumption gone? Way down. It needs a mindset change. Electronics, the way the energy efficiency is going, in my parlance, I think today we are talking about energy efficiency. 5 years from now, we will not talk about energy efficiency also, simply because it will be everywhere. In fact, if something is not energy efficient, we'll be shunning it. It'll be like, hey, which world are you living in? Thank you. I'll leave it at that.
Can I say one more thing?
Yeah, please, William.
I just want to give a shout out to India. Someone mentioned the EESL initiative around LED lighting, and I have to believe, this is my belief, and I would love to see it happen, that if EESL did the same thing in terms of bulk procurements for all of these DC appliances, they could change the global market. I think whether it's for consumer goods, for household goods, or for productive use good appliances, I think India is sitting in a position today to transform the global market around DC appliances. I don't know that they fully embraced that, but if they had an industrial policy that did, I think it would be a huge game changer.
Also, caution. There are also points and observations where when such things are done in bulk and usually through a government-led or semi-government agency, lot of specifications and quality. I think that starts kind of taking a little backseat. So I think what you mentioned about the importance of quality into this new emerging segment and strengthening that quality from standardization perspective, which Venkat and Bimal mentioned. I think that will remain very important. But yes, the need for a strong demand aggregator with the right kind of a financing backend support, I think definitely remains a strong need. My next question is, I think we are just cross our time limit. We will conclude, but like a very quick point, if Venkat and you can, others can support, like what is the key message that we want to give to the OEMs, system integrators, and startups who are already doing some form of solar, DC, or system integration and appliances? What is the trend that you believe that they should not miss and really start gearing up to this thing, which is kind of inevitable? It will come gradually, but it is inevitable. What do you think, Venkat? You yourself
Okay,
being an
so
OEM.
right, yeah. So see, I think I think Vimal put it absolutely right. There is a mindset change that is needed here because we see this in front of us, and we are going through the traditional phases of denial. At some point of time, we will have to transition from to an acceptance phase. And I think the shout out or the request that I have for the manufacturers is you remember that DC is in for good, okay, and which means that when you are designing your product, figure out if there is a way that you can seamlessly integrate DC in your appliances, in your solutions, and so on, and figure out if if it were to be either intermittent grid or an off grid, does it work as well as in a full on grid application? So if each one of us sort of start thinking with that hat on, I think the adoption is going to be more likely. That's my final concluding comment on this.
No, I think that's a very wonderful suggestion. Like your solution, if it is being designed from that mind, keeping customers and their needs serving across off-grid, weak-grid, and on-grid markets, then we are catering to a bigger segment. What would you think, Vimal, on this suggestion from Venkat?
Absolutely right. I think I'll just add one more thing, and maybe selfishly, because I come from the world of standardization, get involved. Sometimes I find the apathy of some equipment manufacturers who say, well, we don't have the depth in us to do the contribute to standardization. Let the standards be ready, then we'll look at it. That means basically we are giving a message that let somebody else decide what we will do. Is that really 21st century? We have to start managing our own future and destiny by ourselves. And the good thing is that IEC platforms are very egalitarian. Every voice, every individual voice can be absorbed to build a consensus. Of course, we'll go with consensus. But if you're not at the table to provide your voice, you're anyway out of the consensus. Get involved. I think that's the biggest challenge I find with the equipment manufacturers sometimes, who say, well, somebody else will do the work, I will just follow the standard. Then you are anyway behind the game by at least 5 years, because standardization is one of the first things which takes place before devices come in the market. Get involved today so that you can shape the markets of the future. Thank you.
That is a very full of wisdom, Vimal. Thank you. William, your parting thoughts on this point. What would you ask the OEMs? You are already a coalition of multiple of them. What is that ask to really see maybe a significant uh, adoption of, let's say, solar water pump in Africa? I'm just making it very, very specific so that you can think about what is that thing that as OEMs, you want to tell them that, hey, this is what we need to drive this adoption in the customers.
Yeah, I don't think it's an OEM issue. I think it's a policy and finance issue. So I'm going to just hand it back to my colleagues, and they're the experts here. So I don't think I have much more to add there.
Okay, I think this is good. With this, I thank our wonderful speakers to share and make time for this wonderful session and knowledge shared today. I thank all the participants for being very active throughout the session and sharing questions. Few of the questions we have tried to take up. Some questions related to safety of DC systems and all other things. I think we will have a separate webinar focused around standardization and design oriented thinking. I think we'll try to take up those questions in that time. So thank you, and stay all safe, and we look forward to really work together, get involved, as Vimal's message stands strong. Get involved to mainstream LVDC and rising applications. Thank you, everyone.
Thank you. Thank you, everyone.
Thank you.